All right, so in this class, we will just solve question 5. Question 5 has this question, which is here. It says solve the second order differential equation. So in order to solve this differential equation, what you must note is, so let's write our differential equation, which is y double prime minus y prime plus 9y is equal to 0. So now you must check the characteristic equation of this second order differential equation. So in order to check that, you will just say you check using the discriminant, which is b squared minus 4ac equal to 0. So now this here is given by r squared plus br plus c equal to 0, where this a, b, and c are just the coefficient of, so a is the coefficient of y double prime, then b is the coefficient of y prime, and then c is just the coefficient of y. So now you need to get those there. So how do I get that? So I will say my a is 1, so I'll just remain with r like that. Then my b is -6. Then my c is 9. Then from here you have to factor out this. So this is r here. So you have to factor out. So factoring out, you have your product is 9 and your sum is -6. So your factors are going to be -3 and -3. Because when we multiply this, we get +9. When we add, we get -6. So this is going to be, this factors out to r minus 3, then r minus 3 equal to 0. Then you just have r equal to 3. So both of them just give you r equal to 3. So now, when we have a differential as a second order differential equation with r where these are equal, they are the same, you have that. So the purpose of us doing this, we want to get our y1 and our y2. So our y1 will be given by, so e r1 to the power x like this. Then y2 is going to be equal to x e r1 x like this. So r1 or just r in this case, because it's just there's only one. So in a case where these were not equal, meaning this x here, where you see this x would not be there. So you just have y1 equal to e raised to r1 x like that, and y2 equal to e r1 x. So e r2 in that case, because they would be different. But if they are the same, you have to write it like this. So now this means our y to solve the equation, our y is going to be equal to, so our y is going to be c1, then you write e, so e r1 x, then plus c2 e r, so x here, then r1 the power x. So this is how it's going to be. Now we will replace here. So we start with this part. We replace y1 is going to be e to there. So r1 we found that's 3, so to the power 3x like that. And then the other one here, y2 is just going to be x e to the power 3x. Then you replace in there, you get c1 e to the power 3x, then plus c2, then x e to the power 3x. So this is going to be the general form of this differential equation. So this is how it's going to look like this. Do I have any questions?
No, no questions.
All right. So then the next one, you have this here. So the next one says, let P equal to, so you have a point P1 equal to those there, x1, x2, x3. Then you're told, okay, so this here, there was an error. This has to be y1 and then z1. Yeah, y1, z1, x1, y1, z1, like that. Be a point on in space, and P2. So P2, okay, so this here we can name it not P2, let's say P naught. P naught be equal to, then that's it, x naught, y naught, z naught, like that. Then be any point in the what, in the plane. Given that n, so this n like that, that's our normal, is B, A, B, C is the normal vector to the plane. Show that the distance between P, so this point P which we had, and the plane is given by this formula. So we must show that the distance is that. So now how are we going to show that the distance is equal to that? So to show the distance, we'll say, let's find the vector. So we'll name it B. So if we found the vector B, which is vector, this P naught and P1, like this. Yeah, if we're to get the product of this, we're saying these two vectors. So this is going to just be equal to, so you get the last points where you're ending from, that's P1. So you have x1 there. So that will be x1, then minus where you're, that's the first one where I started from, that's a P naught, and that will be x minus x naught. Then that just gives you y1 minus y naught, and then z1 minus z naught. So you get that. Then you already know that your normal, we've been given in the question, is just this one here. That's your normal. Then from here, we see that the distance P1 to the plane is the absolute value of the projection of the projection B along what, n, along n. So it's a projection, and now by vector projection, that is just going to be equal, we say d the distance, vector projection, so to be P, so we're saying bn along, B along n, like that. So it's going to give you this, and this is just going to be divided by n multiplied by b over modulus of n, like that. So this is how it's going to be. So this modulus with n there just is going to be the magnitude of this normal vector. So now we use this what we have here in order to prove. So we will say now, if we have this here, so we say distance is going to be equal to, so we get now the values that that is, so the plane, so a plane is given by the formula, which is ax naught plus by naught, like this, plus cz naught plus d equal to 0. We must keep this in mind. So now we are multiplying here by the normal by the what, by vector b. So this here is b, which we found. The normal is the one we've been given in the question. So it's a, the dot product we're doing. So a, we multiply with this part, this component, which is x1 minus x naught, like that. Then plus b is going to multiply y1 minus y naught, then plus c is going to multiply z1 minus z naught, then modulus like this, then divided by So here it's the magnitude of the vector. So the magnitude of that vector. And that the magnitude of that vector is just going to be given by, or we know the magnitude is just magnitude of the normal vector. So each component, you just square it. So b squared plus c squared. So here, this is going to be what? This is what you're going to get. So now from here, what you do is you can, so let me erase this part. So what you do now is you can multiply. So when you multiply what is inside there, you multiply the a with whatever is inside, you're going to, okay, so we'll multiply. So we'll get a x1, then minus a x naught, then you have plus b y1 minus b y naught, then plus c z1 minus c z naught, then divided by that there, plus c squared. So from here, you can then factor out. You can say this is going to be equal to modulus. You just leave the ones with the ones. That's ax1 plus by1 plus cz1. So this is going to be minus. Then you can have the other one. So you factor them. It's going to be here like this, plus by naught plus cz naught like this. So you can see the minus factored out the negative, and we've put this there like that. Then over a squared plus b squared plus c squared. So now here, what do I do? So from this point, look at this point where we have, so we have ax naught plus by naught plus cy naught. So this equation here, which we wrote, is the equation of what? Of the plane. So now we can see from this equation that if I take this d, the other side, it becomes negative d. So meaning this part here is just equal to what? Negative d. And I can replace that, then it will multiply by this other negative, which will make that positive. So I have modulus of ax1 plus by1, then plus cz1. Then the negative multiplies by that other negative, it becomes a positive d modulus over, then that is going to be, okay, so run out of space there. Let me write it here. Modulus of ax1 plus by1 plus cz1 plus d, like that. Then this divided by root of a squared plus b squared plus c squared. So this is how we're getting that formula, and you can just write hence shown. So hence shown. Yeah. So we've showed that when we have those, we can get that formula there. Okay. Let's move on.
Wait, sir,
Yes.
could you please repeat that part where you said when the d crosses to the other side, it becomes negative d? I'm a bit confused there.
Okay. So we have this equation here. As we said, this is the equation of a plane. So when you have an equation of a plane like this, from here, the equation of a plane always has a what? Has a constant d, which has no variable. It's just d. It's just a constant like that. So we can, when we move this constant to the other side, meaning the equation is going to be ax naught plus by naught plus cz naught equal to negative d. Now we have this part here, and we can observe that it's equal to this other part here. They are the same. So if these are the same, I can replace this part by negative d, because it's saying this is equal to negative d. But then this negative d, you can say this negative multiplies with a negative d, and I just have positive d. So that's how I get that positive d there. Yeah, and this then gives me what we are looking for. So hence shown.
Okay, thank you.
Okay, so we move on to the next one. Okay, so the next one says, hence otherwise find the what? The distance between the points. So between those points, we must find now the distance there. So we've been given this point, that point, 0, 0, 1, and the plane, then containing, so the plane contains the points, that one and that other one. Those are the points in the plane. Then that point there, 0, 0, 1, this is a point in space. Then you want the distance from that point to the point on the what? On the plane. So let's say that's our plane there. Then we've been given vectors on the plane. We have 3 vectors on the plane. So we use these 3 vectors in order to find, first of all, we know from our formula that we have. So our formula is here. So our formula is D modulus A x 1 plus bx. Okay, this is y1 plus c z1 plus d, like this, then divided by root x squared b squared plus c squared. So what you have down here, this is squaring, is just the normal what? The normal vector. And also these variables a, b, and c are from the normal vector. So it means we have to find the normal vector. To find the normal vector, we have to find the cross product of these vectors. So the normal vector is going just to be equal to, so you need to find AB, then you find the cross product between AB and another point, which is AC in this case. You have to find the cross product of this. So before we find the cross product of that, we must find AB. So AB, of which can be found, this is just the same as saying B minus what? A. Vector B minus vector A. So now vector B, what is our vector B? It's 0, 5, 1, then minus our A is -1, -2, then -3. Then you get from here, so 0 minus -1, then that is just going to be +1, then 5 minus -2, so the negative multiplies the negative, you get positive, and that will be 7. Then the last point is just going to be 4, like this. So this is what you get. Then you do the same for C, and you do the same procedure for C. For AC, just find that this is going to be equal to -1 and 3, 3, like that. This is what you're going to get. From here, we can find now the cross product. So we must find the cross product. So the cross product of what we're now calling to be our normal, because we said n, we've said n should be equal to a, b, like this, cross product of a, c. So this is just going to be, so you put j, k, and v, and I mean I, j, and k, like that, to denote unit vectors. Then you put in now the first part of the first vector, which is 1, 7, and 4. Then you have -1, 3, and 3. So what you do here is you're saying this part. So in order to find for this one here, you say this part and this part goes, then you find this minor axis here. So you get the variable of this one is just it's just 1. So then you find the determinant of 7, 3, 3, 4, 7. So you multiply this by this one, we get 21. Then multiply that by that, we get 12. 12 minus 21, I must get 9. This gives me 9. So it means 9i is the first one. Then I do the same for the other one. So for the other one, for j, so it's going to be this one, this will go, this part goes, and the entire one, this one will go. Then I remain with 1 and 3, like that, and -1 and 4. So you have a minor that remains to be 1, 3 here, 4 and negative 1. Then already here, remember the sign is supposed to be going positive, negative, positive, negative, positive, negative. So now when the first line, which is, so this was positive, here to be negative. So we already have a minus there. Then here this multiplied by that, you get 3 minus, then this multiplied by that, you get negative 4. And you have this is going to be 7. So that's going to be 7, negative 7, j. And then to get the last one, meaning this one, cancel out this one and that one, then you remain with a minor, that's 1, negative 1, then 7 and 3. You find the determinant of this one, which is just going to be, so 3 by 1, you get 3. Then negative 1 multiplied by 7, you get negative 7. Then that you multiply, you just get 10. So that there is just going to give you plus 10k. So this is your what? Your normal vector. So you can write that, say, okay, so you can write that your normal vector is just equal to, so 9, negative 7 and 10. So this is your normal vector. 9, negative 7 and 10. 9, negative 7 and 10. So now from here, we found our normal vector. So let me erase, let's make more space. Okay, so found that normal vector. Can write it, let me write it on the side here. Say our normal vector is just equal to 9, negative 7 and 10, like that. Then the next thing you do is you just say, okay, let P that be X, Y, and Z, like this. This be any point, just any point on the plane. So this will be any point on the what? On the plane. Then you get A, P. So you can do this with any of the vectors that we use. So you can do this with either A, B, or C. So I'll just use A in this case. Then this is going to be, so from the point P, that's where I'm ending from. So P, that would be X, then minus your A there is negative 1, so it will be plus 1. Then you have Y, so it will be plus 2 for Y, then Z to be plus 3. So you get this point here. So when you get this point, what you do next with this point is, as you saw when we were driving, we had n multiplied by that vector over then n, like that. So now this here is what we are from finding here. This is our AP. Then you have to multiply that with a normal vector, which is the one we found. The reason why we're multiplying is order to find. So what is just here on top is this is just the equation of a plane. So now to get this, you just say AP like that. Then you're multiplying with the n. Then what is your n? So you have 9. So 9 is going to multiply x plus 1 like this, because it's dot product, plus, then you have, so plus, of course, there's a negative sign there, so meaning it's going to be negative there, negative 7, then y plus 2, then plus 10 multiplied by z plus 3, like this. So you get this here. So when you get this, you can multiply that throughout, you get 9x plus 9 minus 7y minus 14 plus 10z plus 30 is equal to 0. So this must be equal to 0. Then this implies this is going to be so 9x minus 7y, then plus 10z when you add 9 plus 14 plus this is minus, yeah, negative 14, then plus that 30, you get 25. So be equal to 0. Yeah, you get 25 equal to 0. Then from there, you can now get from the formula that we had, or the formula of distance, what is on top there is modulus of x1, like this, plus by1 plus cz1 plus d, like this. And of course, we can see this is what we have here. So now we can replace that, which is 9x minus 7y plus 10z plus 25, like this. Then where there is x, you replace the point which you were given to say here in the question. Hence, they're saying find the distance between the point. So the point you're given, that point is what you replace where there are values here of x, y, and z, like that. So replacing that, you have 9 multiplied by 0 minus 7 multiplied by 0 plus 10 multiplied by 1, then plus 25, like that. So that is going to give us, okay, so that there is going to give us 10 plus 25, and this is just going to be equal to 35. Then you have what you're dividing by, so you're dividing by a squared, b squared plus c squared. So this is going to be root of a squared, our a, we have 9, our b is going to be negative 7, like that, then our 10 squared. And this here is going to be 81 plus 49 plus 100. And this is just going to be equal to root of 230. So this is what we get. Now we put everything together. So on top we had 35, down we have root of 230. So distance is just equal to 35 over root of 230. And then you can write units because you don't know. Yeah, but because it's distance, so it must have units. So like that, that's how you find the distance there. Okay, are there any questions? All right, so
No.
next question, final one, which is this one. So this question says we must solve this, we must integrate that. So to integrate this, we integrate this by parts, and what you have to remember is the ate, like this, L, which is for logarithmic, inverse, algebraic, then trigonometric, then exponential. So now this is what you're getting to replace to be your u. Is what you're getting to replace to be your u. And then what you will do is okay, so you have to get your u, your v, your du, and your dv. So from this same question, so we have ln x dx. So we must identify first what is going to be my u. So your u, you check, do I have a logarithmic function in here? Of course I have ln of x. So this is what you are going to say to be your u. Then everything else that remains is going to be your dv. So dv is going to be whatever remains, that's x squared dx. So that's going to be x squared dx, like that. Then you differentiate here. So du is going to be equal to, so when you differentiate that, you just get 1 over x dx. Then this other side you integrate. So when I integrate dv, I just get v. Then integrating this here, I'll get x cubed divided by 3. That's what I get because I add there power 1 and divide by 2 plus 1, which is just 3. So I get this here. So now what I do next is say the integral of this x squared ln of x dx is just equal to u multiplied by v, then minus the integral of v du. So now let me replace what I have. My u is ln of x, then my v is what I found here, x cubed divided by 3 minus my v again. My v is just the same, x cubed over like that. Then du is this here, which is 1 over x. Then it bears like a dx there. So now from here, I can write this to be, so let me write my x cubed over 3 like this, ln of x in front, then minus, here this x can divide into this here, then I remain with the x squared here. Then I can move 1 over 3 to the front, so I have 1 over 3 here, then integral of, I remain with x squared here, dx, because the x has divided into this x cubed. Then from there, what we do next, okay, so we're going to have, okay, let me clear here. So this is going to be, so there you can write that as 1 over 3 x cubed ln of x, then minus 1 over 3. So what do you do when you integrate this? Here you get, so you're adding plus 1 to the exponent, then that's just x to the power 3, then divided by what? 3. Like this. This is multiplying, so don't forget. Then your constant plus constant c. So here when this multiplies, or if you can see, they have a common factor, like this is 1 over 3. Even this one has 1 over 3 and has x. So you can factor out that 1 over 3, x cubed, I mean. Then you remain, the first one, remain ln of x. Then here just remain with the 1 over 3, like that, plus your c. So you have integrated this. You have integrated. That's how you integrate. Do I have any questions?
No, I'm clear so far.
All right. Thank you. So this was the last question. This is the end of this video.